All right, welcome everybody. We are expecting a lot more people. There's a few hundred people who know about this meeting, but they're in a lot of different time zones, and a lot of them will be watching it at different times, I'm sure. Everyone's going to be watching this eventually, but thank you guys for joining the ones who are here. So we have a little bit of an intimate group, so a good opportunity to ask questions. And welcome. We're really excited to be doing this with you. We've been working on this for quite some time. This is our third design challenge. And go ahead to the next slide there. Uh, just a little bit of background. The next slide should be, there we go. Okay. Yeah, a little bit of background. We are the Astro Lab at Texas A&M University. We have been working on this platform called Space Teams Pro for many years, and we'll tell you a little bit about that. And you'll be using that as well as Ross for this competition. We do everything, all kinds of things related to space in our lab, but in particular, mission simulation, space system design, a lot of guidance and control and system modeling and environment modeling. And this has been put together by grad students and undergrads. Uh, a few call outs here. So, we're in the aerospace engineering department at Texas A&M, and NASA Texas Space Grant has been funding. This is our third competition that we're running. NASA Texas Space Grant, which is funding that NASA gives to all of the states in the United States, is sponsoring the development and execution of this. You signed up on their website, in fact, for this. And we also have other sponsors that some of you may have worked with in different countries who you probably heard about this from and signed up with. Uh, and so, and that just depends on which country you're working with. Go to the next slide. I'll tell you a little bit more about the participants in a second. So this is a group we have at the lab, the Astro Lab. These are the team leaders. We have a lot of students. Some of these folks you're going to meet today. You're going to meet some others that are not pictured here. These are the ones who are the leaders of various teams we have that have been part of developing our platform and tools. And and we have a undergraduate research program that we run that has typically 50 to 60 students every semester that these folks you see here lead in various groups related to everything from planetary modeling to guidance and control systems to uh, artificial gravity and the back end software to do simulations and modeling. Let's see, go to the next page. All right, so what we have for this competition, we're really excited. We have 65 teams from a lot of different countries. You can see here the US. This is originating in Texas. We have a lot of Texas teams, but the majority is actually international. So from international meaning outside the United States, but Canada, India, Bangladesh, South Africa, Australia, and Ghana. That's so we're very excited to welcome all of you. And a couple of dates that want to highlight. You guys saw this on the flyer wherever you signed up, but today is our first kickoff, and you can see that we're going to be running here um, webcasts every week, every Monday, while the competition is running to make sure we talk to you, hear your questions, answer all your questions. And we're also, if any team is still trying to sign up, we will take signups up until the end of today. One date in the future here, November 7th, is a qualification submission, and we'll be telling you more about that in a bit. And then the final submission on the 21st of November. And then we'll have winners after that on December 5th. We'll announce the winners. And there are prizes for this competition, but it's a mix depending on where you are, whether we have international prizes or regional prizes. We have some sponsors in different countries that are organizing prizes and for their regions. And so don't have all the answers to those details yet, but in any case, there'll be recognition and some mixture of prizes that's still a little bit TBD. We have some time to work all that out. All right, next. Okay, so the thing that we've been developing for a while, many years in our group here is called Space Teams Pro. And as the first line says here, it's basically a platform with that it intends to enable anyone to collaborate on space mission design. And the cool thing about Space Teams Pro, we'll show you in a video in a second here, but you can do everything from modeling the missions to visualizing them in super high fidelity, but also the physics of the space environment and the physics of the interactions of all the systems, um, and the engineering is built in. So we can model things super accurately. And the whole idea really is to be able to design a mission and experience it, and even train for it ahead of time, and discover all things that you need to fix or change or improve before you actually build the real hardware or fly the actual mission. But even more than that, we are working with NASA on projects to incorporate this in mission control. As you know, we're in Texas. Mission control for human space flight, and the U.S. is in Houston. And I've spent almost 20 years of my life working in mission control and as an astronaut at NASA. And and so we're trying to work with them to make it possible to use this platform during actual missions where you're monitoring what's going on, and interacting with the actual mission, and using your digital twin model of what the entire mission looks like in terms of the systems and the mission operations, and make decisions in real time based on what's going on in the field, in mission control. So we're working with NASA on applications along these lines. So I'm going to show you a video here to give you a sense of what Space Teams Pro is. You guys are going to be getting a free copy of Space Teams Pro and using it. With 65 teams of, we assume there's about 500 students total engaged in this. Everyone's getting a free copy of this. We want you guys to use it, explore it, and create your own missions with it. And so this will give you a sense of what you can do with it. However, for this competition, there's not much you actually have to do. We've built the simulation for you in Space Teams Pro. You're going to see it all and interact with it, but you'll be doing your programming in ROS, robotic operating system, and interfacing with Space Teams Pro. But you are welcome to play with it and create your own missions, anything you want to do, um, during or after this competition is over. So with that, let's go ahead and play the video, and then the rest of my team here will give you more details.
I'll activate the sound and video sharing.
Okay.
Space Teams is a platform and a new paradigm that enables anyone to collaborate on aerospace systems and mission design. Space Teams provides a high-fidelity virtual environment of anywhere in the solar system for the design, simulation, testing, and analysis of human-in-the-loop multi-user missions. It can be used for strategic planning, operator training, scenario-based analysis, and to support real-time operations, including situational awareness as well as virtual engagement. The Space Team's vision is to enable scientists, engineers, and students to share ideas and to contribute to humanity's future in space, while government, industry, and academia can collaborate on open or secure aerospace programs. With high-fidelity, mathematically accurate models of real physical systems, Space Teams provides the tools for engineers and operators to evaluate their systems in a precise virtual version of the intended environment. Space Team simulations can also import any user-provided models, such as CAD, environment models, or system behaviors or algorithms, to create virtually any mission scenario imaginable. In industry, it is often difficult to have different engineering teams collaborate on a single platform. The use of different software platforms often requires the work be redone or simplified. Space Teams avoids these issues by providing the interfaces and integration of all necessary files and tools in one package, including industry standards like NASA Spice Ephemeride data and APIs for Python, C++, Trick, ROS, MATLAB, and other programming languages. Users can plug in their own models or algorithms, while Space Teams provides a precision operational environment. In this example, the Earth, orbital mechanics, attitude sensor, and camera models, as well as thruster performance, is all provided by Space Teams, while the customer has plugged in their guidance, navigation, and control algorithms. Space Teams is also compatible with multi-user human-in-the-loop simulations as well as operations. Mission planning and analysis can be done fully virtually, saving time and money, and that the same capabilities carry over to the actual mission. From the cockpit, spacesuit, habitat, or mission control, all operators maintain situational awareness through mixed reality interfaces such as displays, AR, or VR. In this simulation at the rim of Shackleton Crater, the accuracy of the lunar terrain, solar lighting, and deep shadows make it possible to experience realistic operational conditions. Inside of the habitat, or in the spacesuits or in the rover, resource models are tracking utilization, storage, and generation of all resources such as power, water, and oxygen. The mission environment is rendered seamlessly within the rest of the solar system. A user can travel anywhere and discover the other events that are happening elsewhere simultaneously and within the same simulation. Space Teams hopes to spur creativity and innovation by providing a simple way to design, build, and test models for current and future space missions. Users, teams, organizations, and assets can all have different licenses and authorizations with customizable permissions at each level. Space Teams provides an interface for collaboration, allowing teams from different companies and sectors to work together on the same project. What's possible is only limited by the user's ingenuity. Space Teams Academy is a STEM version of Space Teams that is targeted for middle and high school students. The Academy version encourages innovation and teamwork through a virtual competition to design and execute the best mission to another world. Thousands of students from 15 countries around the world have already participated, and a NASA-funded grant plans to reach more than 10,000 students within the next few years. Thank you for watching, and we hope to see you Starside.
All right. Hello, everyone. My name is Alex Shane, and I'm a PhD student here in the Astrolab. And I'm one of the main architects behind the Mars Autonomous Rover Rally. So I want to kind of give you guys a brief introduction to what you will be doing in this competition. And to do that, I've prepared a video. It's narrated by one of our other team members, Ansh Gupta, who will introduce basically the concept and what you guys will be doing. So with that, let's take a look.
Hello, and welcome to the Mars Autonomous Rover Rally. For this year's Space Teams University competition, we are sending competitors on a mission to Mars in a race to explore the secrets of the Red Planet. In collaboration with the Texas Space Grant Consortium, the Aerospace Technology Research and Operations Lab, or the Astrolab at Texas A&M University, created this competition to inspire students across the world to become the next generation of Martian explorers. My name is Ansh Gupta, an undergraduate researcher in the Astrolab, and I'll be walking you through some important details of this competition. As a competitor, your mission is to conduct a geological study of a 2-kilometer wide crater in Mars' southern hemisphere. Your rover is equipped with a core sampling drill, and Mission Control has asked you to drive to 20 sites around the crater and collect core samples at each one. Your task is to design an autonomous controller to help your rover navigate between these sites and avoid rocks and other hazards along the way. You'll program your controller using the Robot Operating System, ROS, which will send commands to a real-time simulation of your rover in Space Teams Pro. Space Teams Pro is a space environment simulation platform made for large-scale engineering system design, integration, and collaboration. Everything you see here is rendered in real time within Space Teams Pro, including a realistic Martian environment, a physics-based rover, and interactive user interfaces. Within ROS, you'll develop and refine your controller using sensor data from the rover. You will have access to perfect rover location and rotation states, as well as RGB and depth camera images from its forward-facing camera, all provided by the Space Teams Pro simulation and transmitted directly to ROS. In the Martian environment, you will encounter hazards that will impede your rover's movement. These include large boulders, rough terrain, and a dust storm that will affect your rover's cameras. Flipping your rover or getting stuck may end your mission early, and you will receive a score based on the number of sites reached and your rover's driving time between sites. Any time spent extracting core samples is not counted, but this means you may find yourself traversing the Martian surface at night where low light conditions can impact your sensors. For more information, consult our documentation and forums, and thank you for being part of this mission. Your curiosity, ingenuity, perseverance, and spirit will define this race. Let's see where your rover leads you.
Hello, I'm Neil, and I'm also one of the developers of Space Teams Pro. And I'm going to introduce the wiki page. This contains everything you'll need to know for the competition, how to set up ROS. But first, I'd like to mention, if you could click next, this yellow highlighted box shows the subscribe button. And this will let you receive any notifications anytime more information is added. Next page. All right. So click one more time. I'd like to highlight these three buttons here. There's a link to the rules and information, a link to a repository where the code is at Space Teams ROS, and also a link to Q&A discussions, questions and answers. So on this page, on this wiki, you can see information such as success criteria, as well as scoring information. And so anytime you have questions, definitely check this page as this contains everything you'll need to know. And next, we'll show the link for Space Teams ROS. So this is a GitHub repository that contains all the code that you'll need to get started. And it has examples of how to connect the robot operating system to Space Teams. As you can see on the right, there's a quick start that shows you how to clone the repository and set up everything so that your ROS environment can communicate with Space Teams. Next. And this is the discussions page, and this will evolve over time, but this is a good resource to use. It's sort of like a forum where you can ask questions and the developers will answer any questions you have, and it will be available to everyone, so it's a fair competition. Next.
Hey everyone, my name is Ansh. I'm an undergraduate researcher in the Astrolab. You heard my voice in the video earlier. Just a brief introduction on the Rover vehicle. Our Rover is an autonomous robot with the following sensors and actuators: a perfect vehicle position and orientation in the Mars global frame, a RGB camera, a depth camera, and then for actuators, we have steering, acceleration, braking, and reversing. So just a brief introduction on ROS. All competitors are going to have to be interfacing with ROS. It is an open source, customizable robotic software framework and toolkit for the development of complex robotic systems. It acts as a middleware between all of your software components, and it facilitates communication between those components using an asynchronous publish-subscribe architecture. And ROS includes many useful packages and extensions that we're going to be expecting competitors to be using, and it makes it allows a wide applicable usage across many industries, including satellites, humanoid robots, and ground vehicles.
Howdy, everyone. My name is Yotam. I'm also an undergraduate researcher here at the Astrolab. And Connor, could you actually go to the last slide for just 1 second? Yeah, just a quick note about the way that Space Teams Pro is going to interact with ROS is we use two different tools for that, Raspberry Server, and we have our own custom image communication tool. You don't really need to know what these are or how they work, just that you will need to keep them open when you're using Space Teams Pro with ROS. And there's a lot more detail about that in documentation, but it's just something to keep in mind. You can go to the next slide, Connor. So yeah, so the way that you are going to interact with Space Teams Pro through ROS is kind of represented by this diagram. You're going to have your ROS node, which will control your rover. You're going to send commands through Space Teams ROS to Space Teams Pro, which will make changes, control the rover in some way, steer it, accelerate it, whatever. And Space Teams Pro, on the other hand, will be sending constant sensor data to Space Teams ROS, which you will receive in your own code through publishers. And I'm going to get to that in a second. So yeah, this is the way your commands are going to work. They're using what's called a raw service, which kind of looks like this. You'll have on one hand Space Team's Pro node, which is going to be the server. It will advertise a service for, say, acceleration. Your own competitor code is going to be able to send a request to that service in order to request the rover to accelerate, and it will receive a response on whether or not the request succeeded. And then let me go through just what commands we have available for you guys real quick. Um, it's mostly just kind of what you expect out of a rover. Steer, accelerate, reverse, brake. We also have a core sample command for you to initiate the sampling that was mentioned in the video. And we have another command to change the exposure of the camera sensors that you're receiving. And then for the way that the sensors are going to be sent over to you is going to use a ROS topic. It's a little bit simpler. It's pretty similar to the services, but in this case, Space Teams Pro, which you can think of as a node, will publish to a topic that your own code can subscribe to. This will happen many times a second for the different sensors. And anytime you receive it, you will be able to do whatever you want with it in order to control the rover and avoid obstacles, hopefully. On some of the sensors that we have available, and this is not a comprehensive list. We have the only kind of unique one is core sampling complete. That one will only publish when you are done with sampling at one of the points that your rover will need to. All the rest of them are just sensors. So we have the RGB camera, the depth camera, and then we have the perfect state data that was mentioned, and those will also be provided in the local frame as well as the Mars frame. Yeah.
Yeah, so a very helpful tool for competitors to be using is Ross's built-in GUI Arviz. Arviz is a powerful 3D visualization tool for Ross 2 that kind of brings your robot to life. It lets you see what your robot sees from all the sensor data and the camera feeds all in real time. And so you can interact with your camera scenes, tweak settings, add plugins to kind of customize your view. And then this is an incredibly useful tool when you're debugging like a tricky problem or showing off your robot's capabilities. And Arvis kind of makes it all feel very dynamic and engaging.
Hello, I'm Connor Yakovic. I'm lead software engineer at SimDynamics and a research engineer at the Astrolab. So I'll talk to you about the competition rules and submissions. There's not really any restrictions on like what tools you use, what ROS packages you use, other than, for example, they probably should be open source or publicly available in some way. That would mean that somebody else would be able to them without any IP issues, without like if you have if they need to run their software. So that the reason for that is because we require that you give us rights to use and share your Rover code if you submit a submission. So otherwise, you can read the competition rules here as well as on the info page. You can make a Q&A post to ask if you're unsure about anything. I'm sure there'll be a few more specific questions that'll come up. The main thing that is like a limitation on your implementation of this is you're not supposed to do something where you use a previous run of the simulation to make your current autonomous run like trivial. For example, that could be driving your rover manually and then recording the exact path that it followed. And because it's only one simulation that happens, that's used for this competition. That means that the exact same path would work, but it shouldn't be used like that. It should be an autonomous system that can avoid obstacles on its own without prompting of exactly all those obstacles, locations, and stuff. For submissions, competitors will need to screen record the simulation running on their own computer. We did this so that we could have everybody be able to do as many runs as they want and have their best run be the one they submit. There's two submissions. There's a finals qualification submission and a final submission, and that one, the finals qualification is a mostly a completion grade sort of thing to ensure that your team has can submit a valid submission and is familiar with the process, so they don't have to figure it out the day before the final deadline. A qualification submission is required by the final qualification deadline to be qualified to be in the finals and to win a prize. All the scores are validated by us for the top scores, and more information on scoring is available on the info page. For the source code, to make this easier when it comes around to submission time, we recommend that you make your own private repository using the Space Team repo as the template. This will mean that you can control access to your own source code, do collaboration through GitHub and other things. And then the submission requirement is that you have a GitHub repository with your code in it. And it's pretty seamless if you just have this created from this repo here. So everything is all included already. For the software setup, we have information on this on the rules and info page. There are some things that are not yet completed for the competition. We have some changes to do on the Space Teams Pro application. So the current version that's online, v0.39.5, does not include some of those changes. We will announce when the competition version is ready. The setup for the WSL and Space Teams ROS portion is already good to go. You can start on that now and start thinking about how your ROS implementation will look. You also can download Space Teams Pro v0.39.5 right now if you want to. That is a good way to test if your computer is good enough to run Space Teams, as well as to see if there's any setup issues with Space Teams by itself. All right, and then we're done to questions. The main way that you'll be asking us questions during the competition is through this page, but we'll also have weekly info sessions that are in the same webcast form like this, where we'll all be on a call and can answer questions live. And those will be recorded so that people can see the answers as well. Okay, ready to take questions. You can raise your hand and I'll say your name. Also, you can put a message in chat if you aren't on voice. I'm not sure if I can see all the. I should be able to see any people that raise their hand. You can use the Zoom like raise hand button, or you can just turn your video on. Any questions? The specifications. So one of the specifications to run Space Teams Pro, it's on our website. It's off the top of my head, it's basically around the average like minimum spec gaming computer. It needs to have a discrete graphics card. You need probably 16 gigabytes of RAM and at least 6 gigabytes of video memory on your GPU. Yeah, I'll go ahead and paste the link for the competition information in the Zoom chat. 1 second, I'll do that now. Actually, can one of the other team members handle that? I can answer questions. Okay.
I can do that.
Good. The space teams, all the info, like you'll receive a link to this the site as well as the recording for this meeting in an email that's sent out to everybody. Programming languages. We've only tested Python code implementations of ROS nodes, but considering how ROS works, C++ should also be possible. And you're free to do most anything with the code as long as it can be started from ROS. That's the only constraint. We need to be able to you need to be able to share the code with us, and we need to be and you need to be able to interface with ROS because that's where all the communication goes for sending commands to Rover. Gerardo, go ahead.
Oh, I have a question regarding the team members. Is that possible to have members from other universities, for example, outside the US, or is absolutely necessary to have all the team members be part of the, in this case, Texas A&M International University, where I worked? Because I ask this because I have several students outside the US, especially in Mexico. So I don't know if that is possible that those students participate or not. Thank you.
Yes, it is. No problem. There might be some more details to work out as far as how the region for prizes would work in terms of there might be a sponsor that has made a prize for only US people or might be only Mexico, but we'll have more information on that to you later.
Okay. Thank you.
And Neil's posted a link to the competition rules and info page. There's links to the other pages from there. One of the things that we haven't completed our page for yet is the terrain info, like the terrain data. There's good like the altitude data, it's called digital elevation model. The one that we used for the terrain for this competition is available and it's like full resolution on the USGS website. Or it might be. We'll have a link to it when we post that, as well as some sample code that will guide you to how to use it to sample altitude values.
There's some other questions in the chat we could answer.
Okay, yeah, I might have missed one. Go ahead and answer them, Neil, if you see them.
Yeah, so there's one from Patrick. He says, will the Space Sims link and login be emailed to us? And yes, we'll email you the information for the Space Teams Pro website so you can make an account. The login won't be emailed to you. You'll create an account there and log in on your own. And then another question from Mariam was, what are the programming languages compatible with the software? And that would be Python and C++ for your ROS algorithms.
Right. Question from Rajvi. He says, we are trying to find the best route possible to deliver the equipment safely, or do we design the rover parts using the software? So the rover's already set in its design. You get your only interface to like actually impact the simulation is a set of commands involving like the accelerate forward, backward, and steer left and right, as well as the command to core sample. So the challenge involved here is a combination of path planning, knowing with the altitude in mind, as well as any information you can gather from sensors on obstacles around you. Designing a rover controller that can do some sort of control loop, or maybe something more primitive that gets the rover to the destination by manipulating the steering and acceleration commands, and then probably some things to do with optimization of when and what direction you're looking, as well as like path planning for planning out the mission, making sure that, for example, maybe you want to avoid a certain difficult area when it's at night, and you can do it more easily when it's during the day. Oh yeah, also this is a fully like physically simulated simulation. So the rover can flip over, it can hit rocks and bounce off of them. It can get stuck if you try to go over one and you end up being high centered on it. So all that is needs to be kept in mind. Yeah, you're making a video game AI. Rashi says so. It's like a simulated video game which we can change the commands. Yeah, so you this is very similar to what you would be doing if you're making an actual autonomous driving computer for real life, or if you're making one that would work in a video game. Miriam says, can we assume that the rover has access to the Mars terrain data, which can supplement the sensors? Yes, the Mars terrain data exists already, and you can use that as part of your solution. You can use any data. If you have access to other data, we recommend you post it online so that people can look at it. But the um, you can use that data if you find it.
And one addition to that answer is the latitude and longitude is provided for you in the simulation. So that's based on the Mars latitude and longitude. You can use any data you have.
Right. Seog says the 20 waypoint challenge is just for the qualifier or final. So the minimum actual score that you need to have to make a valid submission is hitting one waypoint. When you hit one waypoint, that means that you have a score, which is the time it took to get to that waypoint, as well as the number of waypoints that you went to. So for both the qualifier, well, for the qualifier, you actually don't need to get to one waypoint. You need to um, we'll have more information on this, but the gist of it is the qualifier is just proving to us that you can use the ROS interface and send commands and submit a properly formatted submission. And then for the final submission, you need to get to at least one waypoint. And then we expect that the best solutions will get to all 20. But there are things such as a 1 hour limit to the overall driving time, which will mean that like something that's too slow or something that might need to speed up to meet that time could not maybe not reach all of the 20 waypoints. And that's still a valid score. So it's possible that nobody reaches all 20 waypoints, and then there's somebody who makes it to 15, but then if everybody else made it to 12, then they won. Okay, any more questions? Question from Stefan. Other than this repository, do you recommend any other resources to follow? So the full list is the info page, which is linked here which is the discussions post. That is the rules and info. The Space Teams ROS repository, which has the starter code and all the API documentation. And then we may or may not be sending out lists of stuff we have seen that might be useful. It might be up to you to find all those. There's I can tell you right now, like the nav2 package is used commonly for these kinds of things. And there's tons of other ROS packages online that will be helpful in completing this challenge. Question from Rashvi. Then do we get all the prize money? Yes. Well, more prize details to come out. We have it's a little bit complicated because it's not just one region. So different regions will have different sponsors that will have different prizes. So yeah, it will depend. Oh, I see. We have multiple winner levels. Like there's a first, second, and third place. Despite all of the price details, we will maintain a public leaderboard of the scores, and that will continue after the competition ends. So I imagine we'll probably have it be a big reveal at the end of the competition where we reveal who's first, second, and third. Overall, and then also the prizes. But then after that, we'll maintain a public leaderboard so you can continue refining your design and take the top spot. Driving time of 60 minutes, is that what simulation speed? That means all of the driving in the simulation takes place in real time at 1x. And the time scale happens whenever the you do a core sampling operation, and it skips forward time but doesn't count towards your driving time. There's a counter in the UI on screen of the driving time as it goes up. I'll go ahead and stop sharing here. Weekly meetings necessary? No, they're not. You don't have to be at the weekly meetings. We recommend that you are if you want to get the information at the same time as everybody else. But especially if you are at a different time zone where it's difficult for you to make it to that, or if you have a time conflict, that's fine. You can ask questions on the website as well as using watching the recordings to get the meeting info. They're more help sessions than the meetings. Oh yes, I forgot to say this. It's on our website. Like you'll be able to see this listed in a few different places, but the support at syndynamics.com email is the main support email for this. So you can reach out to us on that if you have something that needs to be private or is like related to something like registration, or if you like aren't on the right email list or something, or maybe you need to like address a problem with like team member assignments or something, that kind of thing. Shiok says, will there be different elements such as human battery resources limitation added as in Lunar Design last year? Oh, no, nice. You might have remember the Lunar Design Challenge last year. So we don't have any of those. There's a we did it on purpose to concentrate on the navigation and kind of physics-based robotic motion parts in this competition. So the only limitations on your design is that it should get to some waypoints, and it needs to do that within the 60-minute maximum driving time. So no score consideration on anything else besides the time it takes you to get to the last waypoint that you got to, and the number of waypoints that you got to. So the primary score is the number of waypoints you get to, and then secondary from that is how long it took to get to there. So somebody who got to all who got to like 19 waypoints and it took them 30 minutes would have a better score than somebody who got to 18 waypoints, but it only took them 10 minutes. Oh yeah, Alex made a note on in the chat here as well. The waypoints are shown in holographic view. Um, in the video, we will have those instead in kind of tabulated data. Also, there's a manual driving mode where you can use your keyboard, or I forget if we have controller support or not. I think it might just be keyboard. You can use the arrow keys on your keyboard to drive the rover in manual mode. That might be fun as well. Like you can see how fast you can get to the waypoints using manual control. Yeah, that won't be part of the competition, at least the main competition. But it might be fun to have like a channel on the in the Q&A uh, section where we can have a leaderboard, a little mini leaderboard of manual driving. Yeah, we recommend y'all to make whatever screenshots and videos and content to like using this, like you can screen record, you can post these things on YouTube and stuff. We would like to see all of that. The rover that's in here is pretty powerful, and in combination with the Martian environment being only I might misremember this, but 38% of Earth's gravity, you can get away with a lot of large jumps. And if you land them, then even the autonomous system, like if you land the jump, then you aren't going to be that doesn't invalidate your run if you did something that might be dangerous. Okay, thanks, Ravi. Right. So the actual Alex put a note in the chat. There would be a labeled version of the simulation which is used for the autonomous runs, and then there's another version which has a few other things turned on, such as the manual control. You're welcome. Okay. We'll wait another minute or so here for more questions, but otherwise, we'll end and we'll see you next week.